So, before we go into electrolysis, let's just think about why we do it. So, in the earth, we have, well, we need a lot of metals because metals are very useful, but in the earth, we normally find metals as metal oxides or reacted with other stuff. So, we don't want metal oxides, we just want the metal. So, electrolysis is used to separate ionic compounds. And in topic 2, we learnt about how ionic compounds are a positive and a negative thing bonded together. So a metal and a non-metal. Before we start, we just have to learn one other fact. If the metal is less reactive than carbon, there is an easier way to separate it. Just do this. Metal metal oxide plus carbon will form the metal plus carbon dioxide. So all you have to do is react it with metal. But the problem is that only works if the metal is less reactive than carbon. So what is the reactivity series? I'll send you this so you don't have to write it down. But it goes like this. It's potassium, sodium, lithium, calcium, magnesium, beryllium, and then it's carbon. Then it's a couple of transition metals. And then it's hydrogen. And then it's copper, silver, gold. There's two ways to remember it. There's like a sentence you can remember about like, please stop calling me a careless zebra, something like that. Or you can remember the pattern. It goes kind of that way, that way, that way, that way, over here, and then copper, silver, gold. But I'll just send you the exact version of the reactivity series. It will be in the notes. So don't worry too much about it right now. So if the metal is more reactive than carbon, we have to use electrolysis. Okay. But we try to react it with carbon instead if it's less reactive because that's just easier. Electrolysis has a lot of steps and requires electricity, so it requires a lot of energy as well. So what is electrolysis? So inside we have a molten version of the ionic compound. So the ionic compound will be something like magnesium oxide or sodium oxide. So inside we'll have the ions of sodium oxide. So sodium is Na plus because it's in group 1, and oxygen is 2 minus because it's group 6. Okay, so we looked at how group 1, group 2 is 1 plus 2 plus, group 6 is 2 minus, so it's on the periodic table. And we connect it to electrodes. We have a positive electrode and a negative electrode, and that's connected to electricity. Okay. What will happen is, also, we have to make sure the electrodes are inert, one positive, one negative. Inert just means unreactive, because when our thing goes to the electrode, we don't want any further reactions. And the last thing is, we add cryolite. So that's CRYOLITE. And that just lowers the melting point. Because we need it to be molten. And if we lower the melting point, it will melt easier without using as much heat. And then the only thing left is just for you to know that opposite charges attract. So the sodium is positive, so it will go to the negative electrode. And the oxygen is negative, it will go to the positive electrode. After you've done that, they could ask you about half equations. Okay, but just remember that opposite charges attract. If it's a positive, or if it's a metal, the half equations are kind of easy. You get the ion, and it always turns into the element, which is what we want. We want the metal. Basically, you know the electrode, it will go to the negative one and it will coat around it, and then you just peel it off, and then you get the metal all by itself. So how would sodium plus turn into sodium? Well, if it goes to the negative electrode, it would just gain an electron, and then it will become normal sodium again. Calcium, if they give you that, it would just gain 2 electrons, and it would turn into calcium. Something turns into copper, so it would have been the copper 2 plus ion if it gains 2 electrons. And zinc 2 plus would just form the normal zinc metal. So any metal, you just have to have that format. The ion plus electron forms the metal. Now, if it's a negative, so the thing that was bonded with the metal, it's a bit more complicated. You have to remember what's diatomic. Anything in group 7, called the halogens, is diatomic, and anything ending in GEN is diatomic, like oxygen, nitrogen, hydrogen. So because of that, if they don't put the 2 there, you have to put the 2 there. So it won't be F, it would be F2. It won't be O, it would be O2. After you finish doing that, you have to make sure you put 2 Br minus. I know it's Br minus because it's group 7, but you have to make sure you put a 2 in front because the product has a 2 in it. After you're done, you have to count how many electrons are needed. So for example, this is a 2 minus. Well, it's a minus, but there's 2 of them, and this is 0. So it would have gained, it would have lost 2 electrons. Okay. And it goes on the other side. So both the left side and the right side have the same charge and the same number of atoms. So basically the half equation is showing that when we did ionic bonding, or when something had ionic bonding, it would have gained or lost electrons. And when we're doing the half equation, we're kind of reversing that process. So we're losing or gaining the electron which it had lost or gained. So as a test, you would never be asked about nitrogen, but let's try it. So it's N group 5, so it's 3 minus, and it would have to form N2. If it forms N2, it forms N2 because it ends in GEN, it's diatomic. It would have a 2 in front of the ion as well. The charge of the ion is 3 minus, so there's 6 electrons which it needs to lose. So then it will have 6E minus to complete the equation. But hopefully, usually it's just like a fill in the gap. You probably won't have to do it all by yourself, but that's the idea. The next thing that is important is that we've just done electrolysis of molten ionic compounds. So why is it molten? It's been melted so that ions are free to move. If it was solid, then the ions can't move to the electrode in the first place. So electrolysis won't be possible. So they might ask you, why is it molten? But the next thing is that we might also do another version. Instead of melting it, we might choose an aqueous solution of an ionic compound. They might say aqueous, or they might say solution, or they might say both. So aqueous just means dissolved in water. But this makes it a little bit harder because let's say we're doing it for sodium chloride solution. Sodium chloride solution has these ions. Sodium is group 1, so it's got Na plus. Chloride is group 7, so it's got Cl minus. But water is H2O, so it has H plus and OH minus. So every time it's in solution, you have to also think about those. So what happens is that out of these four, which two of them want to go to the negative electrode? This one and this one. But only one of them is allowed to go here. And out of these four, this one and this one ideally want to go to the positive electrode, but only one of them is allowed to go there. So there are rules. Okay? So the rules for aqueous solution. So we know that the positive ion goes to the negative electrode. And we know that the negative ion always goes to the positive electrode because opposites attract. But there is a rule for which one, because there's two of them. Because remember, there's H plus and OH minus as well. So for the positive ion, you always pick whichever one is less reactive. That's it. That's all you have to remember. And for the negative ion, you always pick the group 7 thing. If there's no group 7 ion, then it's oxygen. When we do questions, it will make sense what they ask you to understand, but just overall, I'll recap everything. So we take an ionic compound which has a metal in it, and we want to separate the metal from the compound. We can either melt the compound, so make it molten, and then do it, and then the opposite charges attract, or we can take an aqueous solution sometimes. We might have to do that. And then opposite charges still attract, but there's the ions of water, H plus and OH minus, fighting to also get to the electrode. And we need to use the rules on the bottom right to figure out which one will go to the electrode. Okay. That's it. So let's look at some questions. So even if you don't understand it fully, if you memorize these common questions, you'll probably get the marks, especially in the easy questions and probably even in the harder ones. So why does solid magnesium chloride not conduct electricity? If it's a solid, the ions are not free to move. And they could ask different versions of the same question. They might say, what do you have to do to it before you do electrolysis? So you have to melt it or make it molten. The ions are the thing that moves particles around, that carries the electric current. Okay. Next question. We've got molten magnesium chloride, and one of the products is magnesium. So magnesium is positive, it went to the negative electrode. Okay. So it went to the negative electrode. The other product must have been chlorine. It would have gone to the positive electrode. Electrolysis is separating the metal and the non-metal from an ionic compound. Okay. Using electricity. And you can add more detail, like the opposite charges attract. So when the tube was heated, the ions were free to move. If you have lead bromide, lead will go to the negative electrode and bromine will go to the positive electrode. Okay? And for safety, wear gloves, wear goggles, and just be careful of being burnt because there's a high temperature. If it asks you why does magnesium ions move to the negative electrode, just say that opposite charges attract. How many electrons does magnesium gain? So it goes from Mg2 plus and it turns into Mg. So it would have gained 2 electrons. So the answer is 2. Why does zinc chloride have to be molten? So the ions are free to move. Okay. Chloride ions move to the positive electrode. Opposite charges attract. So these were just the easy questions. They can be harder, but because we've done them a few times, you're realizing what kind of questions they ask. And this is mostly it. Okay. So magnesium sulfate solution, because it says solution in it, you have to include H plus and OH minus. And the ions of magnesium sulfate are Mg2 plus and SO42 minus. I'm going to go through the ions with you afterwards for sulfate and nitrate and stuff like that. So the question says, what is produced at the cathode? Okay. So the cathode is the negative electrode. So it could have been any of the positive stuff. It could have been this, or it could have been this. The question asks, why is hydrogen produced instead of magnesium? Do you remember the rule we did? We said that because it is less reactive. Okay. And at the negative electrode, when we have sodium iodide, so that's another question. So let's write out the 4 ions of sodium iodide solution. Na plus for sodium, I minus, H plus, and OH minus. So we look at that and we see, oh, okay. These two would like to go to the negative electrode, but we have to pick which one is less reactive. So we say H plus will turn into hydrogen. And there are 2 reasons. Opposite charges attract, but also hydrogen is less reactive than sodium. Okay. Here's another one. Which element is most likely to be formed at the negative electrode? So it could be any of the positive ions, but the rule is we pick the one that's less reactive. So that would be copper. Okay. When I give you the reactivity series, you'll see. And yeah, we say we have to pick a positive ion since opposite charges attract. But we also have to pick the least reactive one. Okay. So in order to form chlorine, it would have started with chlorine ions. Chlorine ions are 1 minus because it's in group 7. Second, it forms Cl2, so there had to be 2 Cl minus ions. And then that means there would be 2 electrons. Anything in group 7 is the same, so I can literally copy it. Magnesium is a 2 plus, and it forms magnesium by gaining 2 electrons. Calcium also gains 2 electrons to form calcium. So normally it would be that way, but it says the formation of calcium ions, so it's fine. And then the harder one is oxygen. So first, because there's a 2, I have to put a 2 here. But the overall charge of 2O2 minus is actually -4 because there's 2 of them. So that means it lost 4 electrons. That's it. So hopefully you'll just have to fill in the gap. And hydrogen. So I'll pause it. Do you want to have a go? So it's always so if there's a 2 here, I have to automatically put a 2 on the other one. So that means there's 2 of these. And it will always have the structure ion plus electron forms atom, or the other way around.
Mhm.
So we just have to count how many electrons we need. Worst case, you can have a guess, but this is 2 plus and this is always 0, so it should have 2 electrons. Okay, good. Here's a quick question. Why does it contain cryolite? So cryolite lowers the melting point. And then once it's melted, the ions are free to move. Okay. So that's because the ions are free to move, and it has a low melting point. And then this one again, so you just have 3 electrons. Okay. So the answer for question 1 was A. And 2A says the products of ionic compounds can be different if they're molten or aqueous. So if they're molten, if they're aqueous, they contain H plus and OH minus ions from water as well. Okay. So that's what makes the products potentially different. Why do we have to use inert electrodes? To prevent extra reactions. Because inert means unreactive. So the anode is the positive electrode. What would go to the positive electrode from sodium sulfate solution? So the anode is the positive electrode. So any of these 2 would go there. There's nothing from group 7. That was our priority. And the second priority was oxygen. So you don't need to know how this happens, but the answer is just oxygen. Why is hydrogen gas made at the cathode instead of sodium? So hydrogen is made because it's less reactive than sodium. Write the formula of the ions from aqueous copper sulfate solution. So we have copper, which is maybe a 2 plus, SO4, which is a 2 minus, H plus and OH minus. Those are the four ions. Okay. So whenever it's aqueous, always put H plus and OH minus. Good, well done.